Hello, it is Monday, March 8th, 2021, and we are working on the 7-day roguelike challenge. Sorry, my brain just freaked out because, oh, I'm curious what that will do. Okay, yeah, sorry, OBS just minimized itself, and I was like, oh god, what happened? Did I break something? No, it's too early in the stream to break things. Okay, so between between streams, yes, that's the word. I have worked on a couple things. One, I removed the walls. Oh my god, really? More of this already? That's got to be some kind of record for people spamming the chat. Okay, well, apologies to everyone, but I need to get rid of this. Alright. Sure. Yeah, sure. What is it? Sending stuff about buying viewers. Okay. And let's just get rid of that garbage. Alright, apologies. Yeah, that's gotta be some kind of record for bot account trying to do stuff. I really need to look into auto mod and just, auto mod that stuff away. But I don't know. I'm too lazy. Anyway, if it keeps happening, I'll do it, but not now. Anyway, I removed the walls. What I ended up doing was I ended up creating these special tiles that are just impassable, so they'd have the passable flag set to false. Gave them this special sort of editor flag or editor image so that I can remember that they're not passable. So if we look at the UI, I also changed the UI. I don't know if that was shown before, but I don't think it was. Yeah, you note that we can't pass through them, or we can't path through them. Yeah, and so I removed the other walls. These doors technically don't collide with anything quite yet. Eventually I want to make them. I added a little bit in the way of items, so we can pick up items now. We can pick up these axes, and if we throw them, or if we get rid of them, they have a little animation now. It's not a great animation, but it's still an animation, and I'm happy with it. So yeah. But yeah, the axes also, you can see that they have different rotations. So if I pick it up, it has a special rotation because it's a weapon. Shields and things will appear vertically. So yeah, we also can't put things on this belt buckle. We have to actually put them on the belt itself. So yeah, that's what I've been working on. These health and mana things are supposed to be inspired by Diablo. They don't quite work yet, but that's pretty easy. This is your currency. It's called spades. Yeah, so there is that. And there's no real carry limit. I don't know if there ever will be. I don't think there will be. So yeah, also if I hit the tab key, I have this stat screen. It has a nice little animation. This is a die that exists just for testing. The idea is going to be that you can remove it from its little slot there. And if you put it in one of these, it will stick. If you right click, it returns to its original home. So the idea is that whenever I hover over this, what I want to happen is I want the die, or the dice that are assigned to these slots, I want them to highlight in this list. The same thing if I hover over a specific die, I prefer that it highlights in this list somehow. I don't know how I'm going to do that. We're not going to do that today. But anyway, I wanted to show off one of the ways that I dealt with this, because it's hard to notice, but if you look at the the objects that appear below this item in the world, you'll note that there's a couple path objects that appear, and that changes over time. But if I open up the window or open up the stat window, that never changes regardless of where my cursor is. The reason behind that is because I finally went ahead and created an input manager. I wanted to explain a little bit of this because it makes certain things much easier if you set this sort of thing up early on. So the idea is that there are certain game objects that need to read the player input at different times, and whenever certain objects are reading it, other objects need to stop. So for example, when the player itself is reading my input to try to move, what I want, so I have the player reads the input to try to move, but also at this point in time, the inventory is also listening to whatever I'm doing, so that whenever I click on an item, the inventory is actually managing the click and drag part. That's why I can still, that's why I still get the pathing even when I'm dragging an item. So this is sort of a bug in and of itself that we need to fix somehow, which I'll deal with. But, so this means that the inventory object and the player object are both reading the input. But whenever I open up the stat menu, I don't want the player object reading where I'm clicking. So basically what needs to happen is the inventory and the player need to stop reading the input, and this stat window needs to start doing that. So the way that I actually managed to make that happen is with this input manager. The idea is that there's this list, and this list contains groups of input, and only one group can be active at a time. So the idea is that the player group is the default one that's active, and it calls these unity events. So one of them is on the player object, and then the other one is on the inventory. So both the player and whenever the player group is active, both the player and the inventory have their handle input methods called each frame. So this calls an update. And then whenever the stats group is active, only the stats screen has its input or handle input method called. And so it's actually super simple to set this up. Like super simple. It's like very trivial. So I'll just show it off pretty quick so that you can see. So the way that it works is we create this struct. This struct has a name. It has a list of unity event, or it has a unity event. A unity event can have multiple method calls baked into it. And also my microphone is visible. I don't really want that. Yeah, that's fine. Okay, Visual Studio, who cares? Yeah, a single unity event can have multiple method calls baked into it, so this is fine. And there's a bool that tells us whether or not this is the default. Then in the actual component itself, we have a singleton instance of it. We have a list of the layers, and then the current layer is equal to whatever current layers is dot peak. So current layers is actually a stack. The purpose of this is so that you can say the stat screen basically gets put on top of the player input in the stack. That way you can pop the most recent input. So we don't have to remember what the previous input was. The input manager does that for us. So the way that it works out is, with the awake, you just have your typical singleton implementation, and we call initialize. When we do initialize, all we do is we find the default layer, we throw an error if there isn't one, and then we push the default layer. This .head method is a special one. It doesn't normally appear in list. It just grabs the first element from a list. That's all it does. So it pushes the first element from default layers, which should be the only element, into current layers. This just sets the default as the current. And so in the case of update, all we do is we go to current layers, we get the top, and then we find listeners, and we call all of the unity events there. We call the unity event, which calls all of the attached methods. Whenever we want to add a layer, or whenever we want to say have one layer cover another, we use this push layer. So we say push layer and whatever the name is. In this case, we call it in the, I think it's the player controller, find all references. In the input manager component, there's a place that it gets referenced. It's in the HUD controller. It gets done. But for open stat screen, we just show the stat screen, and then we push the stats layer on top. And what that will do is that will find the layer with that name, make sure that there's only one, and then it will push that layer. And so what will happen, so whenever we push this layer on top, the peak will get called, or whenever we call peak again, listeners will point to the new layer. Sorry, peak will point to the new layer, and then listeners will be invoked from the new layer. And basically what this lets you do is it lets you create, menus with different hotkeys, and reusing hotkeys between menus and things like that. And so that's a huge advantage. And so I'm glad we got that set up. I thought this was going to be more complicated to do. I had never really done something. No, I'd never really done it this way. I had always done it with like delegates or something. But this is a much nicer way to handle it. It's not exactly as powerful because you can't have multiple layers active at the same time like I could with previous implementations. There's also the case for like whenever you hit escape, that should work regardless of whether you have the stat menu open or not. So there are questions as to how that's going to work. You know, the escape being like the pause menu or something like that. I think I'm going to just add like a persistent layers group or something, like some list of persistent layers, and the persistent layers are going to just check for like the pause key or stuff like that. But then there's other questions that get raised about that. But yeah, that is what I was working on off screen. And the stat screen stuff, that's just a very simple animation. I'm not really going to go over it. This is a very simple animation for it opening and closing. Hey, how's it going? Lazy is playing. What up, Jesus? Yeah, I know. Long hair. I call Jesus very often. It might be fitting for my my abilities with software development, but who knows? But yeah, how's it going with you? Right here, we're just working on a game for the 7-day roguelike challenge. So what we need to do, the thing we need to do today, is we need to actually get the attack and stuff like that working. Because, yeah, we're on day 3 and we don't actually have the ability to attack other things, or other agents or characters. So exploring science and tech on Twitch. Oh, that's cool. Yeah, there's a lot of cool stuff. A lot of people doing crazy stuff, and yeah, it's fun to find coders. Oh, thank you. Yeah, I've looked at other people programming. I wish Quill still did programming streams. It was really fun to watch him. I'm trying to think. I don't know any good. I don't know any good Twitch streamers that still do coding. I haven't looked at science and tech recently. I know that you can find some, like, you know, low-level assembly stuff, which is always fun to watch. Makes your head spin. Alright, let's duplicate you. Alright, we need to remove the player component from you. Let's set taste, maybe I can suggest. I don't watch anymore. I generally don't watch anymore just because it's not really that helpful to me at this point. But game development, like Godot game development, would be kind of neat if anyone does that. Because I've always wondered how that game engine works, and I've looked into it, but I've just never had the patience to. I've never had the patience to actually get into it. Okay, this is an enemy. Alright, so this should end up being a marble bishop. Yes, okay, and it has weapons. I don't want that. I don't want you to have weapons. Alright, so the first thing we need to know is we need to know if this is an enemy unit. So let's check that out, okay. What we need to say is we need a bool for enemy is enemy. Bool is enemy. So that should be fine. That'll default to false for the player. That's good. And then when I think it's not in the input manager. I think I moved it into the player. Is that where I moved it? Yes. Okay. So what we need to do is this is the crazy part. Okay. So there is a tile. So right here we need to check basically if the tile, no, if the, let's say if this tile, okay. So the current tile, if the current tile contains an enemy and we are adjacent to it. So, that would be here. Yeah, if, or would it? Because we don't want to make a path if we are adjacent? Yeah, basically, well, so there's a couple questions. One of them, we could just not even do this in the find path. That's possible. Another one, in tile, map.move, get agent down. Ah, okay. And there's a tile there. Oh, hang on. Yeah, that's not correct. Really, I think that needs to be no. Alright, this is not correct. Alright, now I gotta think. So there's a couple things that we could there's a couple things that we could end up doing. One of them, no, I don't want, I was gonna say one of them is that we could add a collider. We could add a collider to these pieces. I'm not a huge fan of that. I'd rather have it so that you click on the tile and that tells it what you want to, which tile you want to interact with. But in this case, I think we need to check if the tile is occupied. If the tile is occupied and we are adjacent to it and we're clicking the mouse button, then we want to attack. So we'll say var is var has enemy, lowercase, right? Yeah, has enemy. It's going to be tile.agent. It's going to be, oh, are you gonna, see, you're gonna do that, you know? If I were a JavaScript programmer, I bet you this would work. Oh my god, no, we're not doing that. For those who don't know, this is just a JavaScript idiom, and what this does, this is the stupidest thing ever, but you can see that it changes the type. The reasoning that it does this is because an agent component is a Unity object, and it can be implicitly converted to a Boolean value. So if I do the not thing here, it will convert this to a Boolean value. If it's null, it will end up being true. So if basically this gives me the opposite of what I want, and if I do this, it will give me the opposite of the opposite. Therefore, I basically convert this to a Boolean value. Oh, I'm not doing that. So bad. So bad. Yeah, there we go. Actually, this has an enemy and tile.agent.isEnemy. No. Oh, the agent. Oh, right. It only stores the agent, it doesn't store the unit. The agent and the unit need to point to each other. Also, this should be tile.hasAgent. Agent and tile.agent. Let's say get component, unit component. No, let's do this right. Where is it? We have an agent component, right? Yes, we do. Okay. And then this should just be public unit component unit. Yeah. And the two unit and reference, or the unit component and the agent component need to reference each other. That just needs to happen. So yeah, .hasAgent.agent.unit.isEnemy. So the tile has an enemy if the tile has an agent and the agent is an enemy. Yes, okay. And so the other thing we need to find out is we need to find out if we are adjacent. So say adjacent is equal to, so adjacent is going to be equal to, we need to check, we probably need the map to just check if something is adjacent. Well, actually, we can. Trying to think where the best place to put this is, because I mean I know the math. The math is just mathf.abs of let's say player.agent.x or that minus the tile.x or is less than or equal to 1, And so if we're adjacent to this tile, something like that. That is a, oh, it's not Y, it's C, right. It's lowercase c. Okay. Or uppercase C, God, I can't speak. Okay. So now for adjacent, so if the tile, so say if has enemy and adjacent, and we are clicking, then we want to attack, so say debug.log, and we'll say attacking, and let us interpolate this. We'll just say tile.agent.name, sure, something like that. And we want to return here. But yeah, this tells me that we need to redo a lot of this logic somehow, but I don't know how. Right. Okay. Yeah, so if we go here, no reference, sure. If we click, oh. Oh, huh. Okay. Something's going to no reference. Oh, right, because we need to check if the tile is a thing, right? We haven't checked that yet. Okay. So if tile, for now, can redo this logic later, which we definitely need to do. Okay. No, we still get no reference. Huh. Oh, right, I know why. Because I have not relinked these two. So if we go into prefab, say open asset in isolation, you need to reference, wait a minute, you need to reference you. Why would the unit reference the agent? Maybe it's only the player that references the agent. Okay. I guess that's fair. Array index out of bounds. That's interesting. Why? You, hang on. You are in handle input, you're in here. Handle movement, yes. It should be you. Nope, that's not what needs focus. Why did you end up there? Because the other unit is not marked as an enemy, that's why. Okay, actually if, so it has enemy, actually no. What we need to say is has agent is equal to this. So if it has an agent, if the agent is an enemy, we attack. If tile.agent.unit.isEnemy, then we do the attack. And either way we want to return, because clicking on an agent shouldn't result in anything, just by itself. I mean, the idea of, whoops, I still didn't mark it as an enemy. Yeah, now it's an enemy. Okay. So now walking up here, clicking on you, yeah, we get attacking. Awesome, that's what I wanted. Okay. So now it's a question of dealing damage and all that stuff, and how we do that, which is going to be fun. So, let us think about that. How are we going to actually deal damage? I mean, the obvious way is that we put all that logic in here, in the unit component. but we need to reference, we need like some kind of backing data object somewhere to reference the actual like health and stuff of the enemy. So let's data create, well, do we? That's where it becomes very kind of sketchy. I'm trying to think of how this actually could work. There's a couple of good ways to do it. It just depends on how we want to generate the enemies. I'm going to say that we want all of this to be backed up by some kind of data object. The reason, well, it's really hard to say because these could end up being really complicated objects. And it might be a little too much to put in the actual component. The other thing though is that it makes it trickier to generate, or to makes it trickier to set it up. And I don't want to be too tricky to set it up. I don't want to be too tricky for my own good. Alright, so what we'll do for now is we'll just keep everything on the unit component, and if we need to move it later, we can. So let's say public int health, and this is going to be protected int current health. There will be some kind of healing, but deal with that a little bit later. So at the very bottom here, we can put a public void, or actually no, not here. Technically, I think it is supposed to go here. So we'd say take damage, say int amount, and then what we'd want to say is we'd want to say health is equal to not health, god, what am I thinking? Current health. Current health minus equal to amount. I'm just going to assume that amount is positive. I mean, we could make this a uint, but no point. So we have health minus equal to amount. We'll say if current health less or equal 0, then we do some kind of die. Say public void die. Okay. And then this is just die, yes. And also we want to do a protected bool is dead, just to prevent double death. So we say, if we die, we say is dead, it's true. And primarily we say if is dead, then we just return. If we're already dead, you can't die twice, makes no sense. And then in this case, I guess we're just going to do GameObject.destroy. And then, or not GameObject.destroy, just destroy, yeah. Doesn't really matter, but we're going to destroy ourselves. And that should work. So now all we have to do is in here, say tile.agent.unit. Yeah, okay. If it is an enemy, then we say tile.agent.unit. Take damage, and let's say it takes, I don't know, 1 damage. Yeah, let's do that, and then we can test, killing this thing. I need to actually set up the health, right? In awake, yeah. So in awake, the current health is equal to health, whatever that might be. So in this case, let's say the health is 3. So if I click 3 times on this, it should disappear. Okay, so 1, 2, 3, cool. means death. But the agent component, interesting. So the tile still references the agent. Oh, how are we gonna deal with that, huh? Oh, that's interesting. Because the map component, map component needs to be notified when the agent is removed. So I guess what we would do is we would say, I think we need system.action for this. And then, yes, we need a protected, oh god, which is it? Is it, no, it's, we need a method here. And then we need an action inside of agent itself. Or actually, no, agent could have the callback, yeah, alright. Say on, or not public void, public action. For that we need using system. Say action that takes an agent component. We'd say on death. And really, it's when the unit dies. So I guess we can do on destroy. We'd say on death dot invoke this. So when this component is destroyed, we just notify things that we've been destroyed or that we've died or something. And so in the case of the not tile component, but in the case of the map component, we would, whenever we're registering the agents, wherever that might be, in here, no. Register agents, yes. We could have a method protected void on agent death. This is the agent component, agent. Say agents dot remove agent. And then I think what we need to do is we need to recompute, not recompute passable tiles. Whatever tile, oh no, actually I think that is what we need to do. Because that, yeah, recomputes the agents. So yeah, recompute passable tiles. So yes, register agents, etc., etc. Okay, and then we will say agent dot on death plus equal to on agent death. On agent death. Yeah, I was gonna say that should work. So yeah, now whenever the agent dies, it'll notify the map that it died. The map will remove it from the list of existing agents, and then the tiles will all recompute their values. So now, yeah, there we go. We have no issues, and we can walk through that tile. Cool. Now, let us worry about something like loot tables or, well, there's a couple things we could do now. We could look into, not randomizing, but generating or doing procedural amounts of damage, or we could look into like the different stats that a unit could have. And actually, you know what, I think we're going to do that. What we're going to do is we're going to move the sort of unit stats and crazy stuff like that into some kind of game object and then some kind of scriptable object as well. So what we're going to do, not game object, but just data object. And so in this case, this is going to be called unit. And we're going to set it into its namespace, red plus blue dot game. Whoa, Okay. This is not going to be a mono behavior, this is just going to be a normal object. And then we're going to create a scriptable object, call this a unit definition. So we're going to define all the unit attributes here, and then this is going to generate a data object based on that unit, or based on whatever unit we, whatever parameters we put in here. So, have this, and then this won't be a mono behavior, this will be a scriptable object. And we'll say create asset menu, and then we'll say the menu name is going to be definition/unit. Okay, and then the first thing, this is going to have it's going to have the piece type. This will be the piece. And then we'll have, let's say, public material. And then we'll have, not using, have a bool, and we'll say use random material. We'll have a public int for health, something like that. Alright, and then I guess the other thing we can do is we can have like a list of things this might drop when it dies. So we can have a public, what did I call this? Did I call this, I call it some kind of registry. Yeah, we have an image registry, so we can create a item registry. Actually, let's just grab all this code and we'll say something like this. What do we even call this? Registry/image. All right. This will be registry/item. So the idea behind this is just a scriptable object that can hold a list. So this will be item definition. So this will be a list of items that something could potentially drop. So what we will do is we'll have an item registry, and we'll call this the, I don't know, loot table? Sure. Something like that. And so in the case of, the thing that we want this to do is we want this to generate a unit object. So say public unit, unit, or I guess create unit or something. So what this will do is this will say var unit is equal to new unit. Okay. The piece is going to be equal to, whoops, what am I thinking? Right, we don't have those actual parameters on the unit itself. So we need to copy some of these over to here. And actually, this can be, you can just have the definition. So we can have public unit definition. And what we can do is we can have a public, public int, let's say current health. I'll say health current. So health current, and public int health max. Alright. And then the definition might have a material, that'll have the piece, that'll have the material. The material can be copied into the unit component because it's really determined when the unit exists. I think everything else, yeah. So what we'll say is definition is equal to this. Then we'll say the health current, or actually, this needs to be a property, and we need a protected actual value for health. Because we do need to remember the minimum and the maximum. So we need to say that this is a auto property, the get gives us health, and the set, or actually is the syntax like that? Yeah, okay. So the set is expression defined, and we'll say health is equal to value. we'll say health is equal to mathf.max between, it'll be max of the value or the health max, whichever. Okay, that way we can never go over the health cap, but we can always go under. Actually, no, I don't want this to be a setter. I just want it to be a getter. No, okay, we don't need this then. We'll just say get and then protected set. That should be fine. Okay. And then, yeah, we can just say public unit, and then this will be the unit definition. Okay, something like that. Then for our create unit, we just return new unit with this as the definition. Yes, okay. Then in here, we'll say that the health current, or yeah, health, I usually do it as the health max is equal to definition dot health, and then the health current is going to be equal to the health max. The definition is equal to ourselves, or whatever we pass in. That. So in here, let's use that. Okay. So now we probably want a public void take damage, say int amount. Then we will say health current minus equals to amount. Have a protected bool is dead. Actually, no, just public. I mean, it's good to know if this. It's good to allow other things to know if this is dead. This is a get with a protected set. Is dead will be false. That's good. And then we'll have a public void die. Say if not is, or if is dead, then we return. Elsewise, a set is dead to be true. And then we will have a public action for on death. We need to import system for that. Okay. Yeah, basically what we're doing is we're just creating a data object that can manage all of this stuff, and then Unity will just talk to this. And so we'll say on death question mark dot invoke. And I guess we can pass ourselves if we need to on death of unit, and just pass ourselves. Cool. Say if health current less equals 0, then we call die. All right. So I think all of that is fine. So then in unit component, what we actually want to do is instead of having health and managing all of this ourselves, we want to have a public unit definition. We'll say unit, or no, we'll say definition. And this way we can have a protected unit Then in awake, we'll just say unit is equal to definition dot create unit. Okay. And then in take damage, all we do is we call unit dot take damage, and then we call that for the amount. And in on awake, what we want to do is we want to say unit dot on death, and we want to add our own sort of lambda, say unit. And all we want to do is we want to destroy this. We want to destroy ourselves. So when the unit dies, we destroy ourselves. That's fine. We don't need any of this nonsense. I mean, I guess we could have like a die sort of method, but it doesn't really help. Yeah. Okay. So I think that should be fine. Actually, in awake, we can piece in the material here can probably be destroyed here. Yeah, so what we want to do is we want to say definition.piece.images. Why are you not happy with that? Yeah, definition. Definition.material, and then definition.that, and then definition.that. And we'll deal with the material stuff later. Okay. But yeah, generally that should work. Oh, these are errors, okay. Set player piece type. Ah, right. Okay. Yeah, those are gonna break for the moment, but it should be fine otherwise. Alright. So now, in resources, we have pieces, we have items, those are definitions, those are piece types. So piece types. And now we actually need, well, actually no, pieces, that's fine. This can be units. Folder for unit, or not unit, but units, yeah. And there we go, we can create a definition. I need to basically get all of this into the same thing. Oh, did I misspell? I did. Alright. That I will fix. What is it? It's unit definition. Did I misspell it for item definition? Yes, I did. Alright. So I misspelled it somewhere. Alright. Let us create a definition for units. I guess we'll just say that this is a what kind of player? Let's just say pawn slate. So the material is slate, the piece type is pawn, and then the health, I don't know, sure, 10. Just call this the player, actually. And then the loot table, there is none. Interesting that it doesn't have the bool. Am I crazy? Oh, because I'm not marking it public. Alright. Yeah, okay. And this will be the player, and then the, I guess, enemy? Or we'll call this the, I guess this will be like a rook, like a marble rook or something. Sure. Marble. And then, I don't know, health will be 3. Alright, and so let's just check. So the definition here is the marble rook, and then the definition for you is the player. Okay. So let's just check that all that worked. Okay, slate pawn, marble rook, that worked. So if I click on you 3 times, great. Now everything seems to work a little bit better. All right. Great. My camera is a little bit funny. Let me just look at that really quick. Chroma, yeah, that's fine. That's not fine. Okay. There we go. That should be better. All right. So yeah, now that we have that working, what we need to do, there's a couple things we need to do. We can work on getting them to actually drop the items that they need to drop. I kind of like that idea. Alright, so the idea is that this rook, whenever it dies, it needs to drop something from its loot table. So let's say loot table. or let's say loot tables. Then in this case, let's create a item registry. We'll say, I don't know, loot table, I don't know, 0, sure. Let's put, I don't know, 2 items in it. One of them is going to be null, the other one's going to be, well actually let's put a couple things in it. Let's say a couple different kinds of axes. Alright, so let's assign that to you. Not to you, but to your definition here. Alright. And now that we've done that, when the unit dies in the unit component, so what we need to do is we need to have a public void on death. Yeah, on death. Not public, but protected. And we will say that goes from, or that's on death calls on death for us. You don't like that, why? Does not exist in the current context. You are correct, it does not exist in the current context. But now it does. So they destroy game object, which is destroying ourselves, right, okay. So in the case of dropping stuff on the ground, what we need to do is we need to say, I guess first we say the loot table, whoa. Nope. Loot table is equal to definition loot table. Actually, what we can just say is if this is a thing, or better yet, if it's not, then we don't do anything. Otherwise, we say the index that we want, or no, the item to drop is going to be equal to random.range from 0 to definition.loot table .length, or .elements.length, or .count, I guess. Yes. And then if the item to drop is null, then we don't do anything, because it's possible that things that you could drop nothing. Ooh, is that not, wait, oh right. If definition.loot table, if not, it's going to be this. So basically get a random index, and then we go into the loot table, we find the element at that index. And so if that item definition is null, then that's basically like a blank entry, so we don't want to do anything there. Otherwise, I believe we do an instantiate the item to drop, or no. What do we instantiate? We do item to drop dot, I think it's, no, it's not in hand prefab. It's probably like in world prefab, which I don't think we have set up in here. Yeah, we don't. In world prefab. Okay. And really this is the item in world component that we're referencing. So what we want to do is we want to say, we want to instantiate the item in, or the in world prefab. We want to instantiate that, and we want to instantiate it at the transform.position with quaternion.identity as the rotation, because it'll rotate itself. And then we'll say var item is equal to that. Then we can say item dot definition is equal to item to drop. Yeah, it's equal to item to drop, which is the what's it called? God, the item definition. Yes. You can say item dot refresh graphics. Yeah, something like that. I think that's fine. No, we don't. We want to initialize it, not refresh graphics. Item dot initialize with, oh, okay, with item to drop. Yeah. Okay. And so that should pick something random to drop at our current location. I think that should work. So in the case of items, we grab all of these. We say that the in-world prefab should be equal to the item in-world thing. Yeah, there we go. And I think that'll put it on the ground as well. All right. So let's grab this enemy. Let's create multiple copies of you. And we'll just kill multiple of them and see what happens. So we have multiple copies of you, and then the next thing we want to do is we want to go into their definition and change their health to 1 so that they are easier to kill. Yes, and then their loot table is loot table 0, and that has some stuff in it. Okay. Let's check this out and see if this actually works. If I click you, you do drop an axe. You also drop an axe. Okay, something's broken. Or no, maybe they just rolled that each time? Seems likely that one of them would have rolled nothing at one point. But yeah, these are actual items. We can pick them up, we can throw them away. Yeah, it's odd. You would imagine that one of them would roll a 0. There we go, you rolled a 0. Yeah, they roll non-zero way more often than they feel like they should. Alright, let's create, like, I don't know, 10 entries, sure. No, let's create 0, let's create 10, there we go. And then, I don't know, 20% chance to drop, or no, 40% chance, or, which ones do I have? I have marble, I have granite, I have slate, and I have sandstone. So let's say, like, 30% chance to drop something. Alright, so yeah, now they drop things much less often. Alright. Yeah, they drop things when they die, so I'm happy about that. And yeah, we can pick those up. We could use them if, you know, we could use them if we had that implemented, but we don't. My thought is that you're just going to right-click to equip something, and you're only going to be able to equip either a weapon or a shield. And so that will just be your armor and your defense and your attack, basically. So yeah, I kind of like that. God, we're just burning through stuff way faster than I thought. Always seems to happen. I don't know if I should consider it good or bad. But yeah. Really, there's actually probably a better way to do this. Because I think we can just do, could just have this drop into the world, right? Well, I don't know. That's too much for me to deal with right now. Okay. So, I'm trying to think of what to do next. What I will do is I will go into definition and I'll just remove this because we're not using it right now. And it's just going to confuse me later. So, oh yeah, the next thing we could do is we could have the enemies actually move. And I don't know how that's going to work. I mean, obviously, they're going to try to move towards the player. So it's a question of whether or not we want the unit, if we want that on the unit definition itself, or do we want that in some other component? That's really hard to say. I mean, I guess adding more components is never a bad thing. So sure, let's do that. All right, this should just be an AI component. Sure. This will be namespace red plus blue dot game. Okay. The issue is that we will be trying to move. The problem is the player's tile is not passable. So we would have to compute the path as if it is passable, but we would not want to move into the last tile. So what that all of what that means is very simple. So if we have an enemy, right? Let's suppose we are an enemy. We can, sure, I'll just kill all of you because it'll make this demonstration easier. So if we're an enemy, we're over here and this is the player. Note that we can't actually pathfind to this tile because it has something in it. It's counted as an abstraction. So we would want to pathfind to that tile, or that tile. But the problem is that it's hard to know. It would be hard to know which one we want to pathfind to. Well, actually, that's not true, because what we could do it in a not so great way is where we could get all the adjacent tiles to the player, and then we could try to pathfind. We could check each tile and see what its distance is between us and our current location. So always we would end up moving here, but once this tile was occupied, we'd move here or here. So we could probably do that, and that would let us move towards some target, regardless of what target that is. So let us try that. So what we need to do is we need to figure out. So in our case, we're just going to have a public void move, or I guess run AI, as it might be, or just run actually. And right now, all this is going to try to do is it's going to try to move towards the player. So it's a question of who has the map component. I think it's you, right? Yeah, you do. Okay. So in this case, the AI is going to need a reference to the map at some point. It needs a reference to the map and a reference to specifically the player agent. I think the player component, yeah, the player component has an agent. So what we can do is we can say protected map component, this is the map, and then a protected player component, this will be the agent. Our agent component, this will be the target agent, actually. Just call this the target, yeah. And this will be generic, but in our case, it'll only work on the player for now. So in awake, we want to say map component equals find object of type, and then we say map component. And then the target is going to be equal to, whoops, I want to assign that here. Target is going to be equal to find object of type player component. Okay. Player component dot agent. There we go. And so what we want to do is, in the case of, so whenever we run the AI, we want to find all of the adjacent spaces to the player, or to the target. So I guess what we would say is, I'm trying to think of how to do this in a nice way. So we can say is var adjacent is equal to a new list of, let's say, I think they're tile components, or no, they're nodes, right? No, just say tile components. Okay. And for this, we need system collections generic. Okay, and then that's the way that we're going to compute that is we're going to say for int x offset equals 0, or no, equals -1, x offset less than 2, x offset plus plus. So we're going to compute this based on the offsets. So basically from, the top left to the bottom right, which are the 9 spaces that are adjacent to us, adjacent to whatever the target is. This is the y offset, or sorry, the z offset in our case. So we're basically going from -1, 1 to +1, 1. What we say is if x offset is 0 and, oops, that's that, yeah. And z offset is 0, then we want to continue because this is the center, this is where the target is, so it's not going to matter. It's always going to be occupied. Then what we will say is if, say var, the tile that we're currently targeting is going to be equal to map at the target dot x plus the x offset, and the target dot z plus z offset. Oops. Z offset. So what we want to say is that these are the coordinates. So actually x is going to be equal to this, and z is going to be equal to the other part of this. Is equal to that. Okay. So what we'll say is we want to check if this is on the map, because it may not be. Say if, I think it's map.isOnMap, yes, xz, and map of x and z, if it exists, we want to say if passable, or no, .node.passable. I think that's actually correct. If it's on the map and the node is passable, then what we say is adjacent is equal to node. Or we say adjacent is equal to tile. Or it's map of x, z. Why do you not like that? Oh, right, dot add. So we add the tile. And then in our case, we will say adjacent dot sort. I don't think we're getting the extension methods. All right, let me import extensions. So what we'll do is we'll say adjacent dot sort. Yeah, sort where tile to tile dot. Basically, what we want to do is we want to compute the distance between these two things. So say vector3 dot distance from new vector2. Actually, it really can be vector2 dot distance. We can say that. Actually, there's no point in computing this way. We can say mathf dot power. So no, it's isn't it square root? Yeah, square root between the power of what is it? Is it x minus x offset? Or is it x? Oh god, I can't remember now. It would be x minus, oh, for the love of God. It would be tile.x minus unit.x. Well, our agent actually. Public agent. Agent, yeah. So minus agent.x. basically the difference. I don't remember if it's the... No, that wouldn't matter. So raise that to the second power, then we add the z distance. I thought it was the square root of that. Am I wrong? Am I doing something wrong? Can I implicitly convert from float to int? Ah, okay, right. So what we want to do is we want to say 100.0f times that, and then we cast it down to an int. Okay. So we sort based on that, and then we want to say dot head, or no. Yeah, dot head. So that'll give us the first time, it'll basically give us the tile with the shortest distance, basically. And if, we'll say if adjacent dot count is 0, then we just want to return because we can't move. Basically, this means that the player doesn't have any free spaces next to them. Otherwise, the target or the place we want to move to is equal to this. And so what we would say is, well, the other problem now is that even if we know our destination, we don't know if we can actually get there. So that's another issue. One of the main problems is that the map itself, whenever we call move, we actually need to have a move max distance here. And so what this would do is we would say agent.transform.position is equal to that, nodes.last, right, I remember now. No, we don't want to do this. Actually, or do we? Because it's not nodes.last. Okay, yeah. So what we want to do is we want to say last is equal to, say, path.nodes.length, or let's say .count. If it's greater than the max distance, or sorry, if it's less than or equal to the max distance. Or no. Damn it. If the count is less than the max distance. So if max distance is 3 and then there are 2 tiles, we want to move to the last one. Yes, okay. Is equal to that. So if the count of nodes is less than the max distance, then we move to the last one. Otherwise, we want to move to path of nodes at max distance minus 1. Okay, yeah, that'll work. And this will be the node, I guess? Yeah. So that way we can move an agent some distance along a path. And this should have exactly, yeah, 1 issue. But that's fine because we need to find where player movement speed is referenced. And actually what we need to do is we need to grab this, get rid of it. And then in here, we just move player movement speed. So basically we can target any tile anywhere, but we'll only move 4 tiles to it. So even if we're right over here, 1, 2, 3, 4, we should end up here. Ooh, we don't though. We only end up at the 3rd one. Interesting. Oh, right, because there's some weird stuff with distance. But yeah, this way we can compute a path, and then we can just tell the AI to move to that tile. So I think what we need to do is say math or map dot. I think it's get path or no? Is it, what is it? Map dot find path from our current tile to our target tile. So say map dot find path from the agent dot tile, or no, from map of agent dot x, agent dot z, which is our current tile, to the target, to the tile that we want to move to. All right, and then this is our path. So say if path dot nodes dot count greater than 0, or if it's less than 0, that means that we can't get to that tile, even though there is a free tile, it's a tile we can't get to, so we need to return because we don't want to do anything. And I really should be commenting these. Say no tiles adjacent to target, can't do anything. And then we'll say can't reach. Say can't reach valid tile. So whatever the closest tile is, we can't reach it. This will create issues where it may, if it can't reach the closest tile, even if there is a path around, it may not choose to go to that path. But it's kind of complicated to try to resolve that issue, so I'm not going to worry about it for now. And then finally, if the path has nodes in it, then we'll say map.move, and then we'll say our agent along the current path, and then we'll move it, I don't know, 4 nodes. Okay. So in player component, what I'm going to do is in handle input, what I'm going to do is I'm going to say if input get key down, and we're going to say, I don't know, Q. What I want to do is I want to just test the AI. So say AIs, and I'll say find objects of type AI component, and then for each of those, there's no way. No, we have link, yeah. Weird. I thought for sure that that would return. Oh no, I guess that returns an array. And then we're going to say for each AI to AI.run. Okay. So when we press the Q key, all of the AIs should run. And since none of you actually have AI components, I'll just delete all of you. I'll add an AI component here, and then the agent is going to be equal to this. So let's see what we get. All right. So let us press Q. So something broke. Cool. Object reference not set to an instance of an object. If something, so there's no node. So apparently there would be no tile here. Okay. Right, because not everything has a tile. All right, that's fair. There's a node for every space, but there's not a tile for every space. So like the space above this enemy guy, like it's blank, there's a node there that says that this is impassable, but there's no tile there because there's no need to be. So we just need to check if that exists. Okay, if I press Q, yeah, you move very close to me. Okay. And if I press Q again, yeah, you try to move adjacent. Okay. And let's say I go over here. You can go 1, 2, 3. If I go here, you can't quite end up adjacent to me. But yeah, okay, it looks like you follow me. Okay. Yeah, that's going well. It did look like he teleported, but he didn't. So here, he probably won't end up adjacent to us. Yeah. Went 1, 2, 3, and then ended up there. Then here, 1, 2, 3, and he'll end up here. Yes, okay. Alright, now let's see if multiple AIs can do that without screwing up. And without screwing each other up, because that's the main problem, is that they might end up messing each other up. Alright. But I think when it does find path, okay. So something broke there. So something broke only once, but now we're screwed. Okay. What? Ooh. Interesting. Interesting that we get the error from this. Because really this should be AI component.run in head. Or no, list.count. It's list.last. Where did we get? Let's move there. 4. Am I doing this math wrong? Nodes.last. If it's less than max distance. If the count is, well, the count should never be 0. So yeah, the path is, oh, less than 1. Whoops. Really, it just should be is empty, but, you know. That needs to be there, yeah. So now we shouldn't get that issue. Yeah, we don't get that issue. I mean, really, if they're adjacent to us, they shouldn't be moving. Where's the other guy? Oh, he's probably lost because, yeah, from his perspective, yeah, so he's probably trying to get to this tile, but he can't. He can't. Why wouldn't he be able to? He really does seem stuck. Oh, right, because the closest tile, no. Actually, I don't know why that was happening. That's weird. If we go over here, yeah, we can't do anything until we kill one of you. So you, I think you thought that the closest tile that was adjacent to us was like over here, and you found a path around. You're not moving. Why are you not moving? Because, so the closest tile that's adjacent to us would be, from your perspective, it would be here. And so you should have a path to that tile. But not if you're moving first. But then the closest one that's adjacent should be here. There's no reason that you should be not moving, is what I'm trying to say. I mean, now they're kind of messed up, but yeah. Interesting. Okay, yeah, now you just get screwed up and stay over there. I mean, that might be fine. You know, it might make the AI a little bit less predictable, even though it's technically a bug. Yeah, I don't know what's up with you. Okay. Yeah, I do like that they actually follow us and that we can kill them. I mean, they don't attack, but that's fine. Okay. All right, yeah, I like where this is going. Yeah, now it's just a thing of like line of sight or something. Well, not really line of sight. It's probably just going to be like a range or something. Well, actually, yeah, I don't know. I don't know how it's going to work. I'm actually really happy with that, how they're all following us. It's kind of cool that you went around that way. Yeah, that was much easier than I thought it would be. I didn't imagine that would work so quickly. So let's find out if there's any way we can optimize this. So there probably is. What we could do is we could check if the player, or what we could do is we could check. So what we could do is we could store the path, and then we could do two things. We could verify that the path still works. If it doesn't, we'd have to reroute. If it does, then we could just sit tight. Yeah, I don't know. I have to think about it. Yeah, there's definitely optimizations we can make here. This is not the most optimal way to do this, but it does work, so I'll take it. Now it's a question of how we actually determine when the AI goes. Because right now we're just pressing the Q key to actually cause them to move. So after we move, we want the AI to move, or to sort of take its turn, as it were. And then when that's done, we would get control back. So this might actually be another use case for the input groups. The idea being that once we end our turn, or once we move to wherever we want to move, it's sort of like ending a turn. What we do is we pass it over to the AI. When we pass it over to the AI will push its own input group, which basically does nothing. Basically there's no listeners, it just locks our input, essentially. The AI will push that group, and then then it will move all the AI. Then when that's done, it will give us control back. So what I'm going to do is we have about 30 minutes. I think we can do that in 30 minutes. Well, a little bit less than 30 minutes. It's probably a 20-minute thing. I'm going to take a short break, and I will be back here in 5 to 10 minutes, and we will work on that to sort of finish up the stream. Basically, the implementation we're going to go with is we're going to have some kind of AI controller, and that we're going to press a key whenever we're done with our movement, and that will lock our input and do all the AI sort of stuff. But yeah, we're going to do that whenever we are done, or in a minute. I don't know why my camera just decided to freak out, but it did. Whatever. Yeah, I'll see you guys in maybe 5 minutes, and yeah, we'll wrap this up. All right, and we are back. Okay, so a couple things. What we want to do is we want whenever we're done moving, we want all of the AI to move. I basically want to just move this code outside the player controller. So for right now, I'm going to create an AI manager component. So the reasoning behind this is that I want something to manage which AI are active, which ones can see the player, which ones, basically just which ones can see the player for right now. So what we're going to do is whenever why did you end up here? I'm not going to question it too much. Basically, when we hit a button, we want this thing to figure out which AIs can see us, and yeah. For right now, we're just going to move this code into the controller, or the manager, I should say. So we're going to say public void run AI. Sure. So what that's going to do is that's going to find all the AI. So we can say using system.link for the moment. Yeah, there we go. And so for now, we're just going to keep the player controller here to notify the AI manager. And we'll move this out at some point. Yeah, we'll run AI here. So, now that we have this, this just tells it to run the AI, and it's just going to find all the AI components, and it's going to run the AI on each one of them. I don't exactly want to do that. What I want it to do is I want it to sort of also find we basically want, whenever the AI is running, we don't want the player to be able to do things. So actually, let's just do this let's do this the way that I don't want, and then let's do it the way that I want. So we need to say public, I think IEnumerator comes from system collections, right? Is it collections or is it collections generic? Let's assume it's collections generic. We're going to move this into a coroutine because I want each AI unit to move individually as opposed to moving all at once, so we can see which one goes where. So I think it's IEnumerator, and this will be, well, actually we'll have this protected. We'll say run, I guess, or move AI. Move AI, sure. So what this is going to do, this is going to have these be the AIs, equal to that. And then so we're going to say for each AI var AI in AIs. We are going to say AI.move, or .run I should say. And then we are going to yield return new wait 4 seconds. We're going to wait 1 second between each move. And then we're going to yield return null. Why are you not happy with this? Using the generic type requires cat? No, it doesn't. So yeah, we just get the AIs, and then for each AI, we run it, and then we wait 1 second before we move the next one. So what we want to know is we want to know when this coroutine is done. We will say protected void start AI, and then protected void, well actually no, we'll just say end AI turn. End AI turn. So when we're done here, we end the AI turn. Okay. And so what we want to do is when we run the AI, we want to start the coroutine, move AI, And then I guess we're not going to do anything with this, but you know, or actually we can say debug.log the AI have moved. The AI have moved. All right. Yes, so now we'll know, we'll start the AI move and then we'll end it. And then we'll notice something that I don't want to happen. As soon as I create an AI controller component, of course, or AI manager, I guess. Too many managers. Okay, let's put you AI manager, cool. So, if I hit, or if I move up here, if I hit Q, see they move individually, one after another, and then we get the message. But what you can see is that if I hit Q, I can actually still move around, which is not great. Oh, that might have broke something. No, it didn't. Okay. Yeah, you can see that I can still move around. So I don't want that to happen. And so the way that we can fix that is we can use the input groups. So in input manager, I can create another group. I will call this AI. And I'll just remove this. So this is the input group when the AI moves. And so all we have to do is we have to say input manager component dot instance dot push layer, and we're going to say AI. And then when the AI are done, we just say input manager component. Whoops, I need to have the parenthesis there. Say that dot instance dot pop layer. And so that'll just remove the AI, or the AI layer. It'll remove the topmost layer, which will be the AI layer. Say debug.log, what is it? Debug.log, the AI have moved. Yes. All right. And so now what we will see that when I hit Q, I can no longer actually do anything, which is what we want. All right, and it says the AI have moved. Great. It says same thing. I can't do anything until after that. Yep, there we go. Perfect. So that is one way to do that. What I also want to do is I want, in the map, whenever things move, I actually want them to animate a little bit. But I'm not entirely sure how to do that. Well, I say I'm not entirely sure how to do that. I am, but not. Yeah. Problem is, oh, this is the map component. Okay. So since this is a component, what we can do, there's a couple problems with this. The main one is where all this stuff is situated. So here, for instance, we would need to move a lot of this stuff. Actually, I don't think we can do this today. Well, there's only 2 references. So we can do it, we can probably do it for the AI at least. Basically what we need to do is, where move is called, I think we need a function for whenever it gets to a specific point or something, and then a function for, yeah, it's hard to say. Really, I think this move needs to be, it's really hard to say. This move really needs to be a coroutine. That's really how it needs to work. So it needs to trigger, I guess, a series of coroutines or something. But then the question is, how do we know? We basically need to lock the input until until that coroutine is done. So, okay, let's just create the coroutine. So let's say a protected IE enumerable, or IE enumerator. Sure. We can, yeah, this is move or animate agent. And then we take an agent component agent as the target. And we need system collections, not generic. All right. So now what we can do is we can say, we can animate an agent and then we can take a vector, or no. We can take a, well, that's a question. Because we need to animate along that list. So I guess we can take in a list of nodes, of I node. We can say nodes, and then we can say, or no, actually, what we'll do is we'll take in a list of vector 3. This will be positions. And so what we do is we say nodes. I guess we'll say var positions is equal to a new list of vector 3s. And then we will say path.nodes, or no, for each path, or no, for each node in path.nodes, what we want to do is, if we want to say is if, we'll say current node, or no, we'll say last node, or no, last. We'll say if, or for node, say if node is last, then break. So we just go until we reach the last node, and then we will say positions dot add, and this will be a new vector 3 where the node dot x, yeah, at node dot x 0 and node dot z. So that'll give us the positions, and then what we'll say is in animate agent, we'll say start coroutine animate agent. Wait, did I ever start that as a coroutine? Wait a minute. Hang on, did I just like... Oh, I did. Wow, I typed start coroutine without even thinking about it. That was weird. Alright, so animate agent, and then we'll say the agent, and then we will move it along positions. Alright. So now the agent.position, say for each position in positions, we will, after this, we'll yield return null, and we'll say for in, or float f is equal to 0, f less than 1 second, so it'll be, or no, we'll say half a second between spaces, and then we will say f is plus equal to time dot delta time. We will yield return wait for next frame, wait for end of frame, yeah, wait for end of frame. Wait, no, just yield return null. Wait 1 frame, okay. And we will say agent.position, and then we'll say var start position is equal to agent.position, or .transform.position. We'll say agent.transform.position is equal to vector3.lerp from the start position to the end position, or to the position at f times 2, because we're moving double the speed of a second. Actually, this should be less than 1 plus 2 times delta time. I think that should move at half a second speed. And so we'll just use f, something like that. I think that'll work. And then at the end of that, we say agent.transform.position is equal to position, just to sort of seal it in. All right. And so this should animate the agent from one position to another. So yeah, that should work. Let me see. Probably freak out the movement stuff. Interesting that that broke. All right. So that'll move to there. Oh, right. I'm an idiot. That's why. So what I do is I want to do that first, and then if the node is last, then we break. And there's a little bit of a pause because we're trying to move towards the, or to the first node. But yeah, trying to move to the first node, so it causes a little bit of a headache. But I think if we have this, yeah, it causes a bit of a headache. Now if we press Q, the AI, yeah, they all move. They all move, yeah. All right. So yeah, they all get animated and it all waits for all of them to move. Awesome. Yeah, I kind of like that. We need to fix how all the animations work, but you know, other than that, it's kind of fine. And yeah, of course, we only move 4 spaces along that path. We do have the AI kind of chasing us. Huh, interesting. Oh, what? I was hitting W, not Q. So yeah, those two should not do anything. Because there's no... Well, now they should. But no, I guess it depends on what order they moved in. Because yeah, if those two moved after, yeah, okay. So yeah, long story short, we should be able to move here. Then that should free up some spaces. Okay, I guess not. If we move here, though, we should end up with 3 adjacent to us. Yeah. Even though those two are trying to move to the same space. Alright, we should be able to get 3 adjacent to us. Huh. I guess technically, since this dude moved from there, and you moved from there, if you went first, you would think that this space is the closest? Or this space? No, this... No, the closest unoccupied space for you would be there. So... I don't know why you didn't move. That's the weird thing to me. But yeah, at least we have the animations working and all that stuff. Okay, and that brings us to basically the end of the stream, so thank you guys for watching. Whenever we come back, I think I'll have fixed most of the animation stuff, and also I'll make this screen actually work. There's not really any point in me showing off how to do that. We've worked on enough UI. It's not really that complicated, but yeah. Tomorrow what I hope to do is I hope to have all the items built out. Oh, that was interesting. Hope to have all the items built out so we can work on like equipping and unequipping stuff and the actual damage mechanics and stuff like that. But yeah, until then, later today we will be doing a stream of GeneForge, but that's not going to be at the normal 2 p.m. time. That's going to be at 3. So yeah, I think I'm gonna move that stream to 3 normally. So yeah, we'll try that today, see how it goes, and yeah, I'll see you guys in like 2 hours. Yeah, thank you for hanging out, and I'll see you.